Okay, so we've been learning about graphing sine and cosine functions. Over the past few days, we've talked about taking y equals sine of x and changing it to y equals a sine of x plus c, or y equals a cosine of x plus c. And what that does, that changes the amplitude. Okay, that a value in front is the amplitude, and it changes the vertical shift. So that c value on the end changes your vertical shift. So we've graphed a bunch of functions where the amplitude has changed, the vertical shift has changed, and we've talked about methods to label your graph and whatnot to get you to the point where you can do that easily. Okay, so now today we're going to take this a step further, and we're going to first talk about y equals a sine of kx plus c. Okay, and y equals a cosine of kx plus c. Okay, we're going to talk about this. That k value affects your period. Okay, so k changes the period. Okay, and there's a formula that's used to figure out what your period is when we have that coefficient in front. Okay, to determine your period for any sine, cosine, tangent, cotangent, cosecant, or secant function, you use the expression 2 pi over k. Okay, that tells you the length of the period for any trig function. Okay, and what we're also going to do, which I've run out of room to tell you about, but what we're also going to do is talk about one final thing. We're going to talk about phase shifts, okay? But let's first handle the period and talk about how that changes, and then we'll move on to phase shifts in a few minutes. Okay, so just to refresh your memory, let's do two problems where we just have an amplitude change and a vertical shift change. So let's graph y equals -2 sine of x plus 3, and then let's also graph y equals 1/2 cosine of x minus 2. Okay, if I'm going to graph y equals -2 sine of x plus 3, let's first change this to be a smaller grid. The first thing that I'm going to do is I'm going to label where my vertical shift is, so where my median line is. And I'm going to label my maximum and minimum values. So in a different color, I'm going to go up 1, 2, 3 spaces. Okay, and I'm going to create a dotted line here. This represents the midline, or the middle part of my wave. Okay, the next thing that I'm going to do in a different color, just for fun, I'm going to label what the maximum and minimums are of my graph, so that when I do go to graph this, I can do it quickly and I don't have to think. I can just repeat that pattern, 0 min, 0 max, and do it that way, as opposed to thinking. So the next thing that I'm going to do, and I know I told you to go out 2, 4, 6, 8, but I didn't leave myself enough room, so I am going to just go out 1, 2, 3, 4, and I'm going to label my period in each direction. My period here, there's no period change because there's no k value attached to the x, there's just a singular 1. My period is 2 pi, so I'm going to label 2 pi. Okay, halfway is pi, halfway to that is pi over 2, and 3/4 of the way is 3 pi over 2. And I'm going to do the same thing in the other direction. It's -2 pi, halfway is negative pi, halfway to that is negative pi over 2, and halfway to that is -3 pi over 2. Okay, now I'm ready to graph, and I'm going to think about the pattern for sine. The pattern for sine starts at 0. We know that the sine of 0 is 0. And then from there, it goes to the max. However, this negative sign in front means that we're going to go to the minimum value first. We're going to reverse that. So we're not going to go max, we're going to go min. So what I'm going to do, I'm going to graph the sine of 0, Okay, and then it's going to go, instead of 0 max like it's supposed to, it's going to go 0 min, because we're going down. That negative amplitude says go down first. So 0 min, 0 max, 0. Okay, and then in the other direction, I'm just going to continue the wave. Okay, I'm going to go up to the max, to 0, to minimum, and then to 0, and now I'm ready to connect the dots. So connecting the dots, I do have a nice neat sine curve, just like that. Okay, and I'm done. We can talk about domain and range here. Okay, the domain for all of your sine functions are always going to be all reals. Your range is what's going to change based on your amplitude. And if I look up top at my amplitude makes my sine curve go from +1 to +5. Okay, because the amplitude is 2 and we started at 3. So we're going out 2 from there. So my range is y such that y is between 1 and 5. Okay, moving on to see what that looks like for cosine. This one's going to be a little trickier because the amplitude is only a half, so we're going to have to maybe zoom in a little bit on this guy to make sure that we are doing it accurately. So I'm going to start off by labeling my x and y axis. This one is going to go down 2, so I'm going to put my x-axis a little bit further up so that I have room. I'm going to go 1, 2, 3 spaces down, and then I am going to label where that midline is. That midline is going to be at -2. Okay, the reason why I went out 2 spaces is so that I can label my maximum and my minimum without having to go in between any of those boxes. So my maximum amplitude is a half space, so half the way to 1. And my minimum value is a half space, so half the way to -3. And now I'm going to start graphing my cosine function. Before I do that, I probably want to label. So let's go out 2, 4, 6, 8, because I like the space, and then 2, 4, 6, 8. I didn't really leave myself tons of room, but I'm going to do it anyways. And then I have my period, which is 2 pi, half of that is pi, half of that is pi over 2, and 3/4 of that is 3 pi over 2. And I'm going to label that in the other direction, -2 pi, half of that is -pi, half of that is -pi over 2, and 3/4 of the way is -3 pi over 2. So now I'm going to go to graph cosine. Okay, cosine starts at its max, and this has a positive amplitude, so I know that I'm going to continue to start at my max. So here I am, and I'm starting at the max. Okay, cosine then goes max, and then 0, min, 0, max. And then continuing the wave in the other direction, I'm going to go 0, min, 0, max. Okay, and now I'm ready to connect those dots and graph my cosine function, and I have a shorter wave for this guy. Okay, and now I can talk about domain and range here again. I can say that the domain is all reals because it always is. We can go on forever because of coterminal angles. And my range is a little trickier here because I am a fraction. My range goes from -3/2, so -1.5, to -5/2, so -2.5. Oh, I should have reversed those, but let's pretend that I did that the right way so that we can move on. So next up, we're going to erase all of this, and we're going to talk about changes in period. Okay, first I'm going to start with a simple function. Let's do y equals, let's do the sine of 2 theta plus 2. Okay, and talk about what happens there. So the general form of your sinusoidal function is going to be a sine k theta plus c. And that k value is used to find period. That k value does not represent the period, it's used to find the period. So that k value is what we use to find the period, and to find the period we do 2 pi over k. Okay, so I'm going to take this and I'm going to dissect it a bit before I start. Okay, so here I have that k value of 2. Okay, so 2 pi over k tells me that 2 pi over 2 is my period, and my period is a length of pi. Okay, essentially what that means is I'm doubling that angle, so I can get all the way around the unit circle twice as fast because I've doubled that angle. So that means that I complete all of my values for sine in half the time, essentially. I've cut my period in half because I'm doubling that angle, so I'm moving faster. So now, when I go to graph this, what I want to do is graph a positive and a negative period, just to show the entire graph of my sine function. So this change in period is going to change the way that I label the period of my graph. So I'm going to go and start this the exact same way that we have been starting it. I'm going to label the x and y axis. Okay, and then I'm going to label where that midline is. That midline is at positive 2. I'm going to go up 1, 2, 3, 4. Here's positive 2 right there. Okay, so I'm going to label that midline. I don't have an amplitude change. We're only going to go up 1 in each direction, so I'm not going to label that piece. What I am going to do is go out 2, 4, 6, 8 in each direction. 2, 4, 6, 8, and I'm going to label a positive and a negative period. In this case, the period is pi. So instead of labeling negative 2 pi to pi, I'm going to label negative pi to pi. Okay, and then I'm going to approach this the exact same way that I approached labeling my period before. I am going to, my whole period is a length of pi, so half of that is a length of pi over 2. A quarter of that is a length of pi over 4, and then 3/4 of that is 3 pi over 4. Notice I've always been saying it that way. It's to set you up for this moment. You're welcome. Okay, so I'm going to label the negative period in the same way that I labeled the positive period. I have negative pi for my total distance. Halfway is negative pi over 2. Halfway for that is negative pi over 4, and then 3/4 of the way is negative 3 pi over 4. Okay, so notice that order that I labeled those in. It's helpful. Okay, now that we have the period labeled, we have the vertical shift labeled, we're ready to graph. So I'm going to go ahead and start graphing. I know that the sine starts at 0. Okay, and then it goes to a max. Notice here that the max is now at pi over 4 instead of being at pi over 2. But if I were to plug that in, if I were to plug that into my equation at pi over 4, when theta is pi over 4, okay, the sine when theta is at pi over 4 will be the same as the sine of pi over 2, okay, just to illustrate what that period change means. That means when I'm at pi over 4, I'm really doing the sine value of pi over 2. So that's why we're at a max already there. So it goes 0 max, and then 0 min, and then 0, and then I'm going to continue the wave pattern in the other direction. Minimum, 0, maximum, 0. Okay, and now I'm ready to connect the dots. We'll do this in purple just for fun. And here I have a negative period and a positive period graphed. I could talk domain and range if we wanted to. Instead, I'm just going to move on to cosine and talk about another period change. So let's say I have y equals, let's make this a little bit more complicated. Let's do negative 3 cosine of theta over 2 plus 1. Okay, so we're going to make this as complicated as we can. So now if you notice, there's an amplitude of 3. Okay, and that negative means that my cosine is going to start at the minimum instead of starting at the maximum, because that negative says, flip-flop that maximum and minimum. Okay, so the amplitude is 3. That's my maximum distance from my midline. Okay, that negative says that cosine is going to start at the minimum. Okay, notice how I'm taking notes on this. That theta over 2, what that means is 1/2 theta. Okay, so my k value is equal to 1/2. So if k is 1/2, 2 pi over k is 2 pi over 1/2. So it's 4 pi. Okay, so that is my period. My period is 4 pi. Okay, and just to think about that, because it's 1/2, what that means is every time I plug in an angle, I cut it in half. Okay, so if every time I plug in an angle, I cut it in half, by the time I get all around the unit circle and I get all the way around to 2 pi, I've actually only gone a distance of pi because I'm cutting that angle in half. Okay, so it's going to take twice as long, so it's going to double the period. Make my period 4 pi instead of 2 pi. Because it's going to take twice as long to go around the unit circle. Every time we plug it in, we're cutting it in half. Okay, and then one more thing, my midline is going to be at +1. Okay, so now I'm ready to go ahead and graph. I'm going to graph this nice and big so we can see all of the pieces. So here we have the y-axis. I know we're going up to +1, but I need a little bit of space to mark all of the amplitude changes, so I'm going to do this just about in the middle. Okay, here is +1, 2, 3, 4, and then I'm going to go down 3 spaces in the other direction. So here I have +1 for my midline. And then I have a maximum value 3 spaces above that. And then a minimum value 3 spaces below that. Okay, so this represents the bounds of my cosine function. Okay, the next thing that I'm going to do, I'm going to label the period in both directions. I have 1, 2, 4, 6, 8. My whole period length is 4 pi. We only have to do a positive and a negative period in each direction. 2, 4, 6, 8. Okay, so negative 4 pi. Okay, then I'm going to start labeling the other pieces. Half of 4 pi is 2 pi, so that's halfway around my period. Half of that is pi, and then 3/4 of that is 3 pi. Okay, I'm going to do the same thing in the other direction. We have negative 2 pi, negative pi, and then negative 3 pi. Okay, and now I'm going to start labeling my points. Cosine is supposed to start at the max, except because this is negative, we're going to start at the min. So here's my minimum value right here. Okay, and then I am going to go back to the midline and then go to the max. Okay, back to the midline and go down to the minimum. Okay, so that's half of my graph. In the other direction, I'm going to go up to 0. I'm going to continue the wave up to the max, down to the midline, down to the minimum. And then I'm going to start graphing and connecting the dots. Here I have my wave. Okay, and I'm all set. Okay, so that is a cosine with a -3 amplitude. So we're starting at the bottom instead. I've changed the period, so it's going to take twice as long for us to get all the way around the unit circle, and we've shifted that graph up 1 space. I could label domain and range, but you get the point. Okay, so now we're going to start talking about our final piece of information. Our final piece of information is taking y equals a sine k theta plus c and changing it to the general form of a sine function. Y equals a sine k theta plus, we'll say b plus c. Okay, every book writes this differently, so pay attention to where the variable is. Some books write it this way, some books write a capital sine bx plus c plus h. Okay, it really doesn't matter how I label this. It matters that I understand the location of the coefficient and what that does to the graph. So all changes here represent your amplitude. All changes here represent your vertical shift, okay, or your midline. Okay, looking at this value, this k value, sometimes it's a b value. That is a change in period. Okay, and then the final piece of information is looking at all of these parentheses all together. Okay, so setting those parentheses equal to 0 talks to you about phase shift. Okay, so setting those parentheses equal to 0. Also, the exact same format for any cosine function, a sine, sorry, cosine, I said cosine, a cosine of k theta plus b plus h. I could also write a cosine of kx plus c plus h. It really doesn't matter how I write it. In other words, it matters that we're paying attention to setting the parentheses equal to 0, and then the coefficient next to my variable tells me what the change in my period is. So what variables you put where is kind of all poetic license in math. So here we go. We're going to start to graph a phase shift and talk about what that looks like. So if I want to graph a really basic phase shift, like let's graph the sine of x minus pi. Okay, and let's make it a +2 just for fun. So notice that I didn't change the amplitude, I didn't change the period, I kept those things basic so that we can just focus on the phase shift. So the amplitude and the period are just your standard. Amplitude is equal to 1. Period, because that k value is 1, 2 pi over k is just 2 pi. Okay, so it's the same period that we're used to. So I have my amplitude, my period, and then here is my midline shift, my vertical shift. From now on, I'm just going to abbreviate that VS because it's easier. My vertical shift is 2. Okay, so now, in order to find my phase shift, the easiest way to remember this is to just take everything in parentheses and set it equal to 0. So we're actually solving for a horizontal shift in the same way that we would for any other parent graph. We're going to say x minus pi equals 0, so x equals pi is my phase shift. Okay, and we're going to abbreviate it that way. Okay, and then I'll talk about what that looks like in a second. So I'm going to get started in the exact same way that I normally get started. I'm going to label things the same way that I always do. We're going to worry about the phase shift at the end. I'm going to label 2, 4, 6, 8 in each direction, 2, 4, 6, 8. And I'm going to label a negative and a positive period in each direction. Whoops, that shouldn't be there. It should be 1 over. I apologize. 2 pi. Half of that is pi, half of that is pi over 2. 3/4 of pi over 2 is 3 pi over 2. Okay, and then in the other direction, we just mimic all of that same language as we see over there, or symbols, numbers. Okay, and then what I'm going to do is I'm going to go up 2 spaces. So here I go, up 2 spaces. And my amplitude is just 1. So actually, I'm going to go up 2, 4, 6, like that, just so we can see the whole graph. And I'm going to label my midline. So when I label my midline, here I am, this is where my graph is starting. I know where my maximum and minimum are. So now let's talk about if there wasn't a phase shift, where would this sine function be? So the sine function would go like this. It would start at 0, it would go max, 0, min, 0. And the dots would be connected just like this. Okay, but that's not the graph of my function. My function now has a phase shift. So now, instead of starting at 0, my graph is going to shift over by pi. Okay, so this point that I see at 0, because of this phase shift, is going to shift over a length of pi. So it's going to end up here instead. Same thing up here. This point right here at pi over 2 is going to shift over a length of pi. Okay, so what I do when I label my phase shift, I know that I'm going to go pi over. So from where I'm supposed to start, I start pi over, and then I start just mimicking my points. We're starting at 0. Next up is my max, 0. Next up is a minimum. And then I connect the dots from there. So my phase shift actually goes like this. Okay, so I've shifted everything over. So now I'm going to continue this backwards, okay, because my phase shift is supposed to shift plus pi in each direction. What that means is the point that should have been over at negative pi over 2 is going to be at pi over 2. And then we're going to have another point at 0, and then max, 0, min, 0. So here we go. I have my sine function. I've shifted over a whole pi. Okay, so all of my points for my graph are shifted over a length of pi. Okay, shifted over a length of pi. So you can see that, that everything shifted. Okay, next up, let's do the cosine function, and then let's do a couple all together. So let's do 2 cosine of x plus pi over 2 minus 3. Okay, just to add a few things into the mix. Okay, here I have an amplitude of 2. Okay, remember that cosine starts at the max, and because this is positive, it's going to stay starting at the max. So it starts at max. I have a vertical shift of negative 3. Okay, and then my other piece of information is my phase shift. That's our new piece of information. My phase shift is x plus pi over 2 set equal to 0. So it's negative pi over 2 spaces. Okay, so that's what I'm going to do. That is my phase shift. Okay, so now I'm going to go to graph. When I go to graph, I'm going to label everything as best I can, as straight as I can. I have negative 3 for a vertical shift and an amplitude of 2, so I'm going to go up a ways so that I have room to graph this. Okay, and then I'm going to go down 2, 4, 6, 8. Okay, and here is my negative 3. And then remember that my maximum values are going to be 2 spaces away. So my maximum values are going to be here and here. Okay, that's my maximum distance away, that's my amplitude. Now I'm going to start labeling things. 2, 4, 6, 8. I'm going to label a negative and a positive period in both directions because that's what I'm requiring you to graph. The period is negative 2 pi because I haven't done anything to mess with that. So I have negative 2 pi, 3/4 of the way is negative 3 pi over 2, halfway is pi, and 1/4 of the way is pi over 2. And I'm going to do that in the other direction. Okay, and then I'm going to start to graph what my cosine should be, and then talk about what the phase shift is. Okay, the phase shift is negative pi over 2. My cosine is supposed to start at the max at 0, but this phase shift is saying, hey, go back by pi over 2. So instead of starting at the max at pi over 2, at 0, what I'm going to do instead is start at the max at negative pi over 2. So here I am. I'm starting at the max here instead, and that is my phase shift of negative pi over 2. Okay, once I figure out where that first point goes, I can just go by the pattern. Okay, the pattern says you're starting at the max, and then you're going 0, and then minimum, and then 0, and then maximum, and then 0. Okay, so that is my whole graph for my cosine. So 0, minimum, 0. And now I can connect those dots. Here I have a phase shift of negative pi over 2. Okay, we went back pi over 2 spaces and then just recreated that pattern. Okay, finally, let's put everything all together. Okay, let's do y equals negative 2 sine of theta over 2. Let's do plus pi over 2, just to see what that does. Actually, let's do plus pi. I like that better. Okay, so all of that's in parentheses, and then let's do plus 1. Okay, so now this kind of runs the gamut of everything you could possibly say. We have a negative amplitude. That means that we're going to go down instead of going up. Okay, so sine is supposed to go 0 max, 0 min. We're going to go 0 min, 0 max. So go down instead of up. Okay, we have a period change here. 2 pi over k is 2 pi over a half, so it is 4 pi. So I have a period of 4 pi. We have an amplitude change here. Your amplitude is equal to 2. That's your maximum distance away. We have a vertical shift of 1. Okay, and then we have our phase shift. Our phase shift we can figure out by doing theta over 2 plus pi and set it equal to 0. Okay, so my phase shift, when I solve for pi, I have theta over 2 equals negative pi. So I have theta equals negative 2 pi. Okay, so that one's not too bad. So that is my phase shift. Now I'm going to start labeling things. I have my vertical axis and my horizontal axis. I'm going to label about halfway because it's an amplitude of 2 and we're only at 1. So I'm going to label 2, 4, 6, and then in the other 2, 4. And then my midline is at positive 1, so here I am at positive 1. And then my maximum is 2 spaces away in this direction and 2 spaces away in this direction. So here I am. Okay, now I'm going to go to the axis and I'm going to label my periods. So I have 2, 4, 6, 8 in each direction, 2, 4, 6, 8. I have a period of 4 pi, so I'm going to label a negative and a positive period. Okay, halfway is 2 pi, halfway of that is pi, 3/4 of that is 3 pi. So I'm going to label that in each direction. I have negative 3, negative 2. That one's kind of easy to label. Okay, and then I'm going to start thinking about my sine curve. My sine curve is supposed to start at 0 and go to the max, and then start at 0 and then go to the minimum. So that's what it's supposed to look like, but we have a phase shift and a negative amplitude, so we're going to have to do a few things here. So now that -2 for an amplitude tells us that we're going to go down first instead of going up, and that -2 pi for a phase shift says that we're going to start over here instead. So instead, we're going to start over here at -2 pi. That's where we are, if you can see. So we're starting here. And then from there, what we're going to do is we're going to go down first. So we're going to go down to the minimum at -pi, back up, up, down, down, up. And if you look, it actually created the exact same graph because we had a negative amplitude and we had a -2 pi phase shift, so it ended up actually graphing like there were no phase shift, which is kind of awkward and uncomfortable when you think about it, but it makes sense based on the information that we were given. Okay, one more, and we'll be done. Let's do y equals the 2 cosine of, let's do x over 4 plus pi over 2, and then plus 2. So here my amplitude is 2, my period 2 pi over k is 2 pi over 1/4, so it is 8 pi. My vertical shift is 2, and then my phase shift is taking the parentheses and setting it equal to 0. I have x over 4 plus pi over 2 equals 0. X over 4 equals -pi over 2. So x equals -2 pi. Okay, so here you have what our phase shift is, and I found that just by cross-multiplying, no big deal. So I have my phase shift, my vertical shift, my period, and my amplitude to graph. Now I'm going to go over to my graph, and I'm going to draw a vertical line and a horizontal line right about here in the middle. Okay, I'm going up 2 spaces, and then I have an amplitude of 2, so hopefully I have enough room. I do. So here is my new midline. Okay, down 2 puts me right on the axis, and then up 2 puts me up there at +4. Okay, I'm going to label out 2, 4, 6, 8, 2, 4, 6, 8, and I'm going to label a negative period and a positive period. My period's -8 pi, half of that is -4 pi, half of that is -2 pi, and then half of that is 3/4 of that is 6 pi. So if you notice, that's nice. It's 2, 4, 6, 8, so that was convenient. Okay, and then I'm going to start thinking about the cosine. The cosine's supposed to start at the max. This one is going to start at the max because it's a positive amplitude, okay? But this one has a phase shift of -2 pi. So instead of starting at the max at 0, we're going to start at the max at -2 pi. Okay, and then next from that, because we're shifting over -2 pi spaces from what our initial point is supposed to be. So next, from there, we're going to go 0, min, 0, max, 0. And then in the other direction, we're going to go 0, min, 0, 0. And now we can connect the dots. And here we go. We have a cosine with a negative phase shift of -2 pi and an 8 pi period. And we're done. So practice your homework, refer back to this video. There are several other instructional videos on the course website to walk you through how to graph these more complicated sine and cosine functions, and good luck.